Hey everybody, so we're in the middle of section 1.7 in pre-calc, and we're using our calculator to make a curve. And so we've got some data here talking about temperatures, the high and the low temperature of the day. And we're going to make a scatter plot and then see if we can make some correlation of how the high temperature relates to the low, how the low relates to the high. And then our ultimate goal after we do that is to do something here. Let's see, it's talking about something about Madison, Wisconsin. So Madison, Wisconsin, we are going to predict the high temperature. So we're going to use all of this data that we have right here. We're going to come up with a scatter plot and a line of regression, and then figure out how to predict some things. So what am I going to do in order to do that? Well, I'm going to pull out my handy dandy calculator. I could totally graph this by hand, but that would be craziness, and why would I do that when I have technology to help me? So think about, how is it that you go in and even start to make a scatter plot? We come over to your graphing calculator and you hit stat. So I'm not sure if you can see my cursor there, but stat is right to the left of the wheel here, so stat. And now what do I want to do if I want to put stuff into tables? Yeah, I've got to hit stat edit. So it's at stat edit, enter. Okay, now it says L1, L2, L3. If you're in a place where you can't change your X values, that means you're in the wrong place. You should have gone to stat edit. Okay, so we're going to start, and I see New York City is 70, and so you can go right over to the high or whatever, but I'm just going to go down 62. Oops, I made a mistake. Whatever do? I just go back and fix that. So I'm going to go through and I'm going to put all of these stats in. I would like you to do the same, and then let's meet back up, push pause, and let's meet back up when you're done. All right, here we are. So I went through and I added all 20 things. And then I checked several times just to make sure, because sometimes, you miss a button or something like that. So I checked, made sure that everything lined up and that all was well. Okay, so now once I've done that, my next thing that I want to do is to make a scatter plot. So how do I make a scatter plot from there? Well, I first have to get out, and then I'm going to go into stat. Nope, that doesn't do it. So how about this? Let's say I'm going to go to graph. Oh no, it didn't work. Whatever will I do? Well, did you turn your stat plot on? So I go to second, y equals, oh, I gotta quit out of there first. So second stat plot, is it on? Oh, it is on. That is awesome. Is anything else off? Nope, okay. So I think we're okay. Now, maybe you don't know this sweet thing, but look at this. Go to zoom, and then look it down here, zoom 9. You might have to go down there, but zoom 9 says zoom stat. That is going to fix your window. Okay, so now I'm going to look back and it still says it have an error. So what am I going to do to fix that? Well, let's just go into graph and check my stat plot. So actually go back into my stat plot and look at mine. So this must have been when I used it last time. If you look at my stat plot, it says L1 and L4. But is that where I have put stuff? It is not. That's not what I want right now. So there's all sorts of wonky things that happened. You just have to keep going through and figure out, all right, what is my issue here? So I just hit delete, and then L2 is what I want. So second 2 gives me L2. Now everything should be better. So now I'm going to hit graph and see if it works. I've got my stat, so it's going to be beautiful. And I'm just going to wait for my graph to show up. So it wasn't showing up, so I paused for a second to figure it out because welcome to college. And what I figured out was I just had to go back in and do my zoom stat again. So here is what everything looks like. And that's all nice and good. And so as I look at it, I'm thinking, oh, that looks kind of like there's a positive correlation The warmer the low, the warmer the actual temperature. It looks kind of like it's going up. So I'm just making some observations. But then I look back over here at my slide, use this function to predict the high temperature for Madison, Wisconsin. Well, how do I get something out of there? And the answer is I have to do a regression. So I'm going to pop over here and I'm going to go to the next slide for a moment. And we're going to try to figure out, so what is it that I want for a regression when I look at it? Well, if I look right here, that looks linear. And I think that what we're doing right now looks pretty linear. So applications, fixed cost plus a variable, linear growth, free fall velocity, simple interest, linear depreciation. There's all sorts of things. Sometimes you'll get a quadratic, like a position during free fall, projectile motion, parabolic, reflectors, area as a function of linear dimension, quadratic growth, all sorts of stuff. Sometimes it'll look cubic, sometimes quartic, sometimes it might look logarithmic. I don't know that I've really used logarithmic, but that might come up in chapter 3. Exponential, that we've seen a whole lot. Sometimes you have exponential decay. Sometimes you get a power function, logistic, sinusoidal, so that's a sine, it goes up and down. So there are all sorts of regressions that you can get. But in this case, I think that I'm going to go with, as we look at, shrink this back down, this looks prettier linear to me. So how do I figure out then linear regression? So linreg. So I'm going to go into my stat, and as I look here, now I want to go to calc. What do I want? I want number 4, linear regression. Now if you look at number 8, that's linear regression as well, but do you see how it writes it in a different order? That's not the one I want. I mean, it could work, but let's just go with 4. So I'm going to look at 4, line 1, line 4. Man, that's off too. So I got to go back in and get into line 2. Just make sure it's all there. Frequency list, store. No. I'm going to go into calculate, and here is what I come up with. So if I were to write an equation, I could use this to do it. So let's come on back over here, and I'm going to go in and write my equation. So as I look, I think I'm going to go, so my f of x equals, usually I go to about 3 places. So I've got 0.9698. I'm going to go about 0.97. So let's go back in there, 0.97. All right, then my x plus 23.015. So there you go. There's going to be in my equation. And so now could I figure out what's going to happen with Madison, Wisconsin? Yep, so take a moment, plug Madison, Wisconsin in there and see what you get. All right, so here I go. I've got my nice little equation, and then I'm looking, all right, what do I want to do with Madison, Wisconsin? The low was 46. Okay, so I'm just going to pop over to my calculator, and I'm just going to plug in 46 right there. And if I do that, let's see. Oh, look, I already did it, and I got about 67.63 is what happened. So I just plugged in my 46. I did 0.97 times 46, and then I added 0.01. I think it was supposed to be like 0.015, but really it's going to end up about 67.63 degrees. So that said, now there are a couple of things that I want to do. So this is my ultimate solution. That's great. But I just want to show you a couple things. So back in the graph, here's the graph. And I just decided that I would have a regression model. So I'm going to put that in. 0.97x plus, oh, sorry. I'm trying to do it on my regular 0.97. Here's an x plus 23.015. And then I'm going to graph that and let's see if, oh wow, look at that. My regression line seems to fit pretty well. So that's good. I'm going to show you one other thing that sometimes your calculator will come up with something that looks a little bit interesting. So I'm going to come back over here, flip through to the next page, like the very last one. And it says this. These graphs are only examples. But depending on the regression type, the grapher might display a number r called the correlation coefficient, or a number r squared called the coefficient of determination. Now, the really nice thing about this coefficient of determination is the closer the absolute value of this number is to 1, the better the curve fits the data. Okay, so if I look over here, back on my calculator, it fits pretty well, but do you see how some are a little bit off? So I'm going to come back here and I can take, it says, note, if you don't have an R value, go to the catalog and put diagnostics on. This actually is super helpful. So let's just do that together. So catalog, that is second 0 right here. So second 0. Now you have to scroll to diagnostics on. Diagnostics is a D, so you have to go way the heck down. And so I go down and I just keep going, almost there. Diagnostics on, that's right here. So there it is, I hit enter, diagnostics on, yep, enter. Okay, so now I'm gonna go back into my stat calc and my linear regression. Okay, there it is, enter, 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 enter. Okay, so here's what we've got. It still gives me the same thing, and then it says my R squared value is 0.807, so on and so forth. So this means it's a pretty good line, but you could get maybe, it's not totally accurate, but pretty accurate. Again, the closer the R squared is to 1, or the absolute value of R squared is to 1, the better off that you are. And so that's one of the things that I've used in my classes over the summer when I'm doing regression lines, trying to figure out what kind of regression this is, just trying different ones until my R squared is as close as possible to 1. So there you go, just a quick how do we use our regression lines, and hopefully that helps with this all. Thanks everybody, have a great night.